Hello everyone. Hello everyone.
Good morning, sir.
Good morning.
Good morning, sir.
How are you guys? Good.
Yes, sir.
Okay. Yeah. So today we are here. There is no such lab for you to do because this week is reserved for discussing about your case study, about your assignment, and the problems you are facing. Right. So if I ask you all, right, let me first shift my screen. And because I want to see each of you, 1 second, view this should be like gallery and yeah. Okay, so how many of you have started doing the assignment? Please raise your hand in your video. Please, there is a button in reaction. Raise hand. Please, everyone raise hand, those who started doing the work on the case study. Those who not, please don't say that you started, because what we are trying to see that uh, are you guys there on the track or not, right? So I can still see half of the population started working. I can see Ali and Nikhil and other people. Have you not started working on the paper, on your case study? Okay. Okay. So let me share my screen and I'll tell you what to do. Okay. Can you see my screen, guys?
Yes,
Okay.
sir.
Okay, good. Now, to prepare the report, here is some guidelines. Right. Let me open that. Yes. So you see the assignment, how your assignment should look like. The first, let me open one of the assignment. So it will become easy for you to see. Let me open one assignment, maybe from my last semester student in the last term. If I can find teaching 880, autumn history, submission by students. Yes. So this is one of the project. One second. Yeah, this is one of the project done by my student, right? This is a different project. So you can see the abstract, the title goes like that, a nice title. Then your name should come and your registration number should come, your school name and the university. Then your abstract will come. Okay. Abstract should not go more than 250 words. Make sure your abstract will not go more than 250 words. What to write in the abstract? You see, I have clearly given you the guidelines. Provide a short description of your work to convince the reader that your paper is worth reading. Make sure the title of the paper is also descriptive. Do not use project 1, 2, something like that, right? To give you the example, few examples, how to prepare your report, you have to click here, examples of IEEE transaction. If you click here, right, you copy link and open it here, right? So you see there are some links I have given to you that how the paper should look like. There are a lot of paper which are open access. You can click on any of the paper and see. The next part of your paper will be introduction. What should go in the introduction? Will you have to read about this. Majority of the references, like the references of your paper should come. There will be no reference in the abstract. Make sure, guys, your references, apart from abstract, your references will come in the whole report. So you see, there is no reference in this abstract, but the abstract will start here. There is a mistake for which I have cutted the marks. Always the reference will start from 1, 2, right? And then 3, 4, it will come, right? In the introduction. So if you want to see how, maybe I have given you somewhere. So I template policy guidelines. So yes, so you can see the structure, click me. So if you copy this link and open how your paper should look like, what you have to write in abstract, you can see over here, introduction. What will go into the introduction? These points about your report you need to put in your introduction section, right? Introduction section should contain 3 or more paragraphs. Now make sure it will not go beyond one page. So for example, if you are starting your introduction from here, it should so see his introduction is finishing here. So that seems fine to me, right? Second part, literature review. So your project, what I have given you, you have to read some papers along with that, right? What you have read, where you are reading the thing from, everything should go into the literature review. What you will be doing in your paper, are you running classification model? What type of classification model you are running, support vector machine, random forest, whatever, how you splitted your data, everything should come in your methodology section, that how you conducted the experiment. So you have gathered the data, you did pre-processing, so there will be a subsection called pre-processing. Then your method section, like for example, in one or subsection, that what method you have used, how you have used it, how you splitted your data, everything should come. And then whatever the results you found, so you see over here, he did literature review. And then in this section, methods. So in methods, this first section, they talk about the data set, what data set they have used, proper referencing of the data set, that where you got this data set from, some of the pre-processing of your data, that how you correlation matrix or whatever you want to do, it's look like some of the plots, right? And then what type of feature engineering you did, like for example, what type of method you used, how you decided to do that, and then what algorithm you used, why you have decided it, right? And how you conducted the experiment, everything. Whatever now finished, your result should come here. That means for experimental, whatever, what accuracy, what metrics you are using, how you analyze, how you present your result, you have to create a table or you want to do a plot, right? What your models are doing, how they are performing, is it making sense or not? Everything should come over here. And then discussion. This section is very important, that towards the whole study, when you were doing the whole study, what you found, what you learned from there, what you have found it, which can't be present in the result. So you think that, for example, if I worked in this way, I would get the more better result. Maybe I'm using random forest, but I don't have time to implement deep learning. Maybe if somebody will implement deep learning, the results can be much more better. I use the split ratio 80-20, but if anybody use, let's say 30 to 40, sorry, 60 to 70, maybe it can go better. I am using k nearest neighbor starting from k is equals to 1 to 10, right? But you think as that k is increasing, the value is also going up, or there is some overfitting going. So discuss everything over here. And then conclusion also not go more than 200 words. And then your reference will come, your references will come over here. This is how your report should look like. Next important point, which I want to show you, is what you need to upload. You need to upload a PDF file. So for example, you see, I have told you, use any IEEE template, sorry, use any IEEE template to create your report. So let's say this is the template which you are going to use. For example, let me open a report that I'm writing this report. You do everything over here. So for example, you see currently you come down, if you click over here. So for example, if you click on the title, it will take you to the title. So see, it came to the title area, right? Where is the title given? Abstract, go here. Yeah. So title means be somewhere up. Here is the title of the report, right? Bear demo here. So let's say you said your report is predicting blah, 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 something, right? Or something. So you just change it over here, right? Then you have to change your name. My name is Heather Raza, right? I remove everything because I don't want these people, right? I remove them. And you see, hopefully my name will come. So, right? And instead of IEEE number, what you have to type? You have to type your registration number. For example, it should be your registration number, guys, which is 6 or 7 digit number, whatever it is, right? Something, that number will come over here. Then which department you belongs to, you can say Department of Computer Science and Electronics Engineering. Remove this all stuff, right? And then this is how you work on the paper. Now you want to work on the abstract. So click on the abstract section. It will take you to that abstract. You have to find where the abstract is going. Other way of doing is do Control F, abstract, right? Right? You do Control F, it will bring you somewhere. Yeah, so here is your abstract. You see begin abstract. So here you have to go to the abstract, right? This is going to be my abstract, and I am not going to write this in more than 250 words. Let's say, for example, right? Whatever you write, it will come over here. This is how you complete your whole report. Those of you who don't know how to work on latex, I have created a YouTube tutorial, right? And that YouTube tutorial is available on my videos. I will share this link with you. So you see writing assignment in latex. This is my video, right? And right? Oh, come on. Right? So you see, I've explained everything over here. Let it get loaded. Maybe my internet connection is a bit slow. Yeah, maybe something. It will come anyway. Okay. So you will watch this video of 16-17 minutes and you will get whole idea how to write this paper. Once you complete your report, right? Once you complete your report, click here. You see what? Let me close the window. Some work is going on. Right. So you have to click here, download PDF. And as soon as you click on download PDF, your report will be downloaded here. You have to upload this report not in the zip file. Make sure you will not upload in the zip file. Copy this report, right, and upload it to your Fraser. Next thing is what you need to do. You need to create a text file. I'm using Word file, right? Sorry. What you have to do, you have to create a text file. So I'm using a free text editor. So let's say the code for your case study you have uploaded somewhere in your GitHub. So let's say this is my repository, for example, where my code is given for the case study. I will simply put the link of the repository and save the file as readme.txt, or you can say github path or repo, something, whatever you want to name, and save it in the format of txt. Okay. GitHub repo already exists. Okay, so you must see somewhere on my GitHub repo.txt, nothing more than that in file, simply the name of the link of your repository. In Fraser, you have to upload two things. First is your PDF file, and second, your text file. Okay, nothing more than that. This is what you need to upload to your case study on Fraser. So you have two submission deadlines. Don't get confused. Both on 14. You have to upload in case study. You have to upload a PDF file and a text file. Is that clear to everyone? Don't upload anything in a zip format. Simply upload PDF and then upload text file. That's it for your case study. Okay, this is how you are gonna work for your case study. About the case study, those people who are struggling still, your task is very clear. You have to identify the health of fetal using cardiographic data, right? The data is available over here. Those who have not downloaded, if you click over here, you can easily download the data. The data has 2,126 rows, 22 columns. This is your data is. You have to classify the data into three classes: normal, suspect, and pathological. So there are three classes in the data. There are three classes in the data. There are three classes in the data: normal, suspect, and pathological. You have to classify your data into these classes. I have given you the whole idea about the project. Reduction of child mortality is reflected in several of the United Nations Sustainable Development Goal, and it's a key indicator of a human progress, right? So we have given you pregnancy-based data. You have to classify these aspects within these 22 columns with the help of these 22 columns and classify the data, right? Whatever you find, you are free to run any algorithm. Please train your model on training data, use validation data to validate your model, and use test set to evaluate your model. Take your direction, your project in any direction. It's up to you, right? Exploratory data analysis is very important, and please present that exploratory analysis in your methodology section, right? If you have any query, please drop me an email. How to get these references? If you will watch this my video, right? I'm not sure whether it's playing again or not. Yeah, let me try. Maybe in some of the part of the video. I'm not sure why it's not running. It should run. Can you try, anyone? Is it running on your computer? Let me give you the link. Please try, everyone. Is it working? So let me know. Is it working for you? Yeah, now it's working for me as well. Okay. Oh, no, it stopped. Yes, it's okay. So if it's working for you, at some stage in my tutorial, I have told you how to cite the reference. So referencing is very important, guys. Don't miss your references, please. Watch the full video. It will definitely help you to solve your task. Okay. It will help you. That's why I have created this. Now, for your coursework in the for your coursework for the lab, right? So you remember in your coursework, so let me open it 1 second. Open it for you, so it will be easy for spring P release, right? This is how you have downloaded your folder. So you must have downloaded week 1, you must have downloaded week 2, you must downloaded week 3. So whatever you are going to upload, it should look like, so you will create a repository, a folder, right? Where week 1, week 2, week 3, week 4, 5, 6, and 7. Do not zip it, right? Just simply upload week 1, week 2, week 3, week 4, week 5, week 6. Do not rename the folders. Week 1 should start with a small letter. Week without spacing, it should be week 1. Week 2 again without spacing everything in small letters. And please do not rename these files. If you will rename these files, it makes my life pretty much difficult for marking. Okay, so problem 1.ipynb. In week 2, problem 1.ipynb. So please do not rename these files. Okay. And if you have uploaded everything on your GitHub, right? So for example, in your GitHub, you have a private repository where you have uploaded everything. That's why I told you to create a private GitHub repository. So let me say lab coursework. So you remember I have asked you to create week 1, week 2 up to week 8. You have 8, week 7 up to now you have created. Once I solved it, I uploaded week 1. In private, I uploaded week 2. In private, I uploaded week 3, right? So everything is private to me. When I solve, I upload. I have not changed the name of the folder. I have not changed the name of the file, right? Once you upload everything over there, what you need to upload is go here, download a zip version. Once you download this zip version, please upload the same zip version to your Phaser in your coursework. Okay, so don't get confused. If you are confused, please watch this lab video again on your Moodle page. It will help you if you are confused. Those people who don't know how to create the folders, right? So you have to create over here, add file, upload or create a new file maybe, right? Here you have to write week 4 because that's not created, and backslash like this, write readme.md and commit new file, right? So now you see, if you go back, your week 4 is created. Come here, now go here, add file and upload your, for example, if I go to my downloads, right, I have a file which I have downloaded. So it may be a problem 1 or something. Any file, for example, I have to upload, I just upload it over there and your task is week 4 is done. So similarly, you create how many folders you have to create? You have to create week 1, week 2, week 3, week 4, 5, 6, 7, 8. There is no lab, so please don't create 9 and 10. So there will be in total 9 folders you will create, and in each folder there is a one file ipynb that you have to upload. Okay, is that clear to everyone? Please don't get confused. If you have any query, just ask me. Now I am ready to take your questions. Please unmute yourself and ask questions. Those people who have their hands up, please make it down, right? I can see Prashant, Shashi, your hands are up. Cynthia. Yes, Dhaval, your hands is also up. Make it down, please. Anyone, any query? Guys, this is the last chance for you to discuss your work. So if you have a query, please let me know now. Yes, Francisco.
I wanted to ask you, when do we use fit and when do we use transform? Because I've seen the code and sometimes we use fit transform and sometimes we only use fit.
So if you want to transform the data, for example, your data is not Gaussian or your data is not normalized, you use fit transform, right? And if you feel your data is already normalized, centered to 0, only fit.
Oh, I see. Thank you. And another question is, how do I split my data into train, test, and validation sets? Because I know how to split into train and test, right? And I've seen that in another course that you can, once you split it into train test, you can split it again and rename the new test set into validation.
Give you an example.
Yeah, I've seen that code and I understand it, but I don't know how to use it. you know, how do I do the validation? When do I use the Y-val and EX-val?
Okay, so let me share my screen and tell you. For example, you have this data set and you have divided your data set into, this is your training, right? This is your validation set. Yes.
Yes.
One second, somebody's on the door. In 1 second, please. Yeah, so we have 3 sets over here. This is training set, this is validation set, and this is test set. Sit down, right? And on training set, you are going to train your model. For validation set, you are going to validate, and this test set you will be used for testing your model, right? Now you are asking where to use this validation set.
Yeah,
now,
because I know where to use the train and test.
Yeah, so for example, you are using k nearest neighbor, for example, or SVM, whatever, right? So if you are using, you decided that I'm going to use it for the 10 times, right? So you have decided that you are going to train this model 10 times. So 10 times you will train this model KNN, right? And use this validation test to find how good it is doing on training, and only on with this validation set. And 10 times it will give you different accuracies. You will note this accuracy over here, note this accuracy over here, here, take their average, and that is your training accuracy. And this test data will be used to calculate your test accuracy. Okay.
Okay. When you say train my test set 10 times, is to change the parameters in the KNN?
Yes, cross-validate the model.
Sir, can I add one more thing?
Yeah.
Sir, I think Francisco problem will be solved if instead of creating separately a validation set, he can use grid search CV or random, because inherently it does the same thing.
Yeah.
So the entire headache of creating a validation set is being solved.
Yeah.
With the grid search?
Yeah, grid. You can use either random search CV or grid search CV.
Yeah.
Grid search, from what I understand,
Excellent.
Just
from model performance, you can just, there's a in sklearn you'll get grid search CV.
Yeah.
And it looks for the optimal parameters, right?
Yes.
Okay.
Guys, give me 2 minutes. There is somebody on the door, so let me finish there and prepare your question. I'll be right back. Okay.
So Shashi, that will solve the validation.
Yes. So inherently, right? What grid search or random search CV does this: once you divide your data into 2 parts, one is your test data and one is your training data. So basically, in grid search CV, what it will do inherently. So suppose you have data 70% of your data in your training data. What it does, if it's a threefold cross validation, it means inherently it will divide the data into 3 parts. So in one part, so and you will iterate, you want to iterate it 5 times, 10 times, that's different, fine. But what it will do, it will take 2 part of the data and the third will kept as a cross validation data for the first iteration. Then it will, on the second iteration, it will again pick 2 randomly, 2 different part of the data of the trained data, and the second data will be your cross validation. So basically inherently it's taking cross validation set randomly from your trained data to train your actual data.
Oh, I see. That's great then. Yeah. Much better than doing more steps.
Yeah, you can you don't have to write the entire code like from scratch. You can directly use the grid search CV or random search CV. It will resolve your issue.
Thank you, Shashin. Thank you.
Yeah, no problem.
Shashin, before you go, Shashin.
Yeah,
bro. My thought is a bit different from yours, but we are all learning here. So if you look at the assignment given to us, we see you could use support vector machine, k nearest neighbor, random forest. So I was thinking that for the validation data, you run k nearest neighbor, random forest, decision tree, then you pass in the validation data. So when the result comes out, the one that has the highest, say maybe it's random forest, You take that random forest and then you pass in the test data on random forest and see what it does. That's what I thought would happen, but you seem to be saying something else.
No. So there is one you are saying about, so in grid search CV, there are one way of only you will pass one model. Similarly, you can also pass 3 to 4 models actually. So apart from these models, it will check the best hyperparameter. First thing it will do, it will for each model pick the best parameters. In the second, and then after that, it will pick the best model which gives the best result for your training data, testing. After evaluating on the test data, it will give you, but it will take a lot of time. So what my approach was initially was that I started from the base model, like KNN is the very simple model. So I hyper tuned my model using grid search CV, and I got my best hyperparameter for this data on the divided data. So for like whatever after getting the best hyperparameter, I will again test my train my model using those hyperparameter only, and then check my performance. And for that, we don't have to only check accuracy. We also have to check F1 score, accuracy, precision, and recall. All the 4 metrics are important. Okay. Then after that, I will treat my KNN as a very base model. So any model which is I will going to test from now should perform better than KNN model. So that's the approach I took. You can also, like how you said, you can directly have this second approach as well. Like you can directly in your grid search CV, you'll directly pass all the 3 to 4 models which you are interested on, and you will get your best model from the grid search CV or random search CV.
Exactly. So if I run 5 models,
yes,
nearest neighbor, naive base, I run all of that. Then I check the F1 score, I check the precision and all that. Then I come out with the model that is best. So I say it's random forest.
Yes,
so I isolate random forest and pass in the test data to random forest and see what it does.
Yes.
Okay. But I'll discuss with you.
Yeah, sure, no problem.
So I'll discuss with you.
Yeah, no problem.
Sorry, guys. There was an ex-colleague of mine who came to see me. Yeah. Okay. So I was explaining you something because I haven't heard the discussion. So there are different ways also, right? Let me clear all right. So the first part which I want to tell you, what Shashi also, I believe, told, you can think of that this is your data, right? And you can use 10-fold cross validation, which is known as 10CV, right? And sklearn, it is available. So what it will do, it will break your data into 10 different parts, right? It will break your data into 10 different parts. For example, these are 10. It will consider all the part here, train the model and test on this. In the next go, randomly, it will leave, for example, this part is left and these part are considered, and then take a test on this model. Similarly, it will repeat the process for the 10 times and give you the accuracy, right? This is one way of doing 10-fold cross validation. There are different ways of doing your cross validations, testing, so grid search, elastic search, there are so many different ways where you can do your hyperparameter tuning also along with this fold validations, right? So My ultimate goal is what I want from you guys, that you split your data into two parts. This part is your training, right? If you wish, you want to create the validation set, it's up to you. So on this whole data, you will do training. And on this data, you will clearly mention the evaluation accuracy on your test data. This is what I want. But what I prefer in general for you to also prepare for your interviews, to split your data into three parts: training, validation, and testing. This is generally what is done in classical machine learning. You train your model on this model, hyper paratune your model. So that means finds the optimal set of your parameters on this data set, and then test your model on this data set. This is classical machine learning. But what other like methods suggest, grid search, it's up to you how you perform it, right? There is no wrong and right, but
Okay.
this is the classical way of doing it.
Okay, can
Is
I
that
ask
clear
you
to
a question?
everyone?
Just before you came in, we were having a discussion with Shashi.
Okay.
So what I said is, you have a model, you split it up into three, right?
Yeah.
And then according to the assignment, you gave us several models we should try: K nearest neighbor, decision tree,
SPM,
and then
regression. Yeah.
Good. So we now set up these models and pass validation data to them.
Yeah.
At the end of the day, we discovered that
maybe in classical machine learning, in traditional sense, you splitted your data into three sets. First set, you train your model. And in second set, which is your validation set, what you will do, you will use that data set to find a optimal hyperparameter. So for example, in K nearest neighbor, you have to find the value of K, right? So you will use that validation set to check the performance. What is the correct value of K? Right? And then when you decided that on this validation, I'm 100% sure now that I'm going to use the value of K is equals to 3, because my K value 3 with this data set, with this validation data set, is doing correct. It's doing best. Now, with the K value is equals to 3, you will take the whole data set, training and validation, merge them, train your model, and then evaluate on the test accuracy. This is classical machine learning.
Okay, but for those of us who are just coming into the field, so I was trying to explain that if I have all those models, K nearest neighbor, decision tree, random forest, then I use my valid.
I think you got frozen, or your voice stopped.
You're muted.
Can you hear me?
Yeah, no, I can hear you. Yeah.
Okay. So I said, for those of us who are new to this field, we are not as professional as you. So maybe in the field, we begin to do that. But for the purpose of this assignment, which we have like 1 month, so I'm saying, if we take all those models, K nearest neighbor, decision tree, random forest, SVM, and then we pass the validation data to them, at the end of the day, they come out with a performance index. So we have what the accuracy is, the F1 score, precision, recall. Then we now discover, say, maybe random forest is the one that is doing best out of them. So I now isolate random forest and then pass the test data to random forest and see what it does.
Yeah, but what I want to see in the report also, that you have not only passed, that random forest is doing good, but to present the result, you have to pass that test data to other model also to show that with SVM, this is coming, with K nearest neighbor, this is coming, with logistic regression, this is coming. So you have to do everything and present your result, and then show which one is the best.
Okay, so it wasn't enough for me to just use validation data to ascertain that random forest is better. I have to also use test data to assert or to run on all of them. Okay.
Yeah. Is that clear?
Okay.
Okay. Anything else, guys? Anything else? Guys, anything else?
At least me, not at the minute.
Anyone? Because I told you this is the last time you have opportunity to discuss, because after this I'll be presenting you the case study, where you will get more idea how to do machine learning, right? But if you want to ask anything now, please guys, feel free to ask. I'm here.
Hello, sir. I'm struggling in the normalization. When I train the data, I got accuracy 99%. And the when I'm giving them same data on one model, so I got approx 94%. So it is correct.
Yes, it is, because some models may perform better, some may not.
Okay. Can I show my code?
No, not here, because everyone is here.
Okay.
What you can do, you can email me. I will check and I'll give you a feedback.
Okay. Yeah. Thank you.
Okay. Anyone else? Any query? Sorry about this background noise, guys. There's some work going on in the behind my office.
Sir, my only question is that after doing all of these tasks, actually, I have reached a threshold of like accuracy of 97% on the test data. So, is there a possibility, like, have you ever seen some, like, in previous where has someone reached up to 99 or more than 99 of accuracy, and that, but in this particular data itself? Because I think I like this is a kind of a threshold.
No, I haven't, because I have not used this data before, right? So 97.
I also have 97%. I'm surprised he says he has 99.
I'm also was like
Maybe you can run more complex model, but unnecessary you are forcing your model
overfit. Yeah,
because 97% is quite decent. So for example, if you are doing 100 tasks, only 3 are getting failed. I believe that's pretty decent accuracy.
In this, sir, when I gone through the actual confusion matrix, so the actual task where we don't want that child to be like misclassified, like, because the dangerous case is where if someone is pathological and we are like assigning him that
Is it coming under false positive or false negative?
No, sir, that is actually for that particular class I'm getting 100% result, like it's correctly.
That's it.
Because yes.
Yeah, that's it. That's what you want to discuss in your report. So this is what discussion is, and this discussion should go in your discussion section in the report, right?
Yeah, yes, sir. Yeah.
So this is how we write. This is how you interpret your result.
Oh, yeah. Thanks a lot, sir.
Yeah. Anyone else? Any query, please come up. If there are not, I'm happy to finish it. Okay, if there is no such queries, let's finish this lab, and good luck to your assignments, to your coursework, and I'll see you in the next lecture, which is I will be presenting you a case study, a whole case study is from the top to bottom, starting from the raw data to make the predictions, and it will give you a more sense about the pipeline of machine learning. Is that okay?
Yeah.
Okay.
Thank you, Professor.
See you guys. See you. Bye-bye.
Bye-bye.
Bye-bye.